Welcome to this video. The experiment name is a study of LSU dryer. This is our LSU dryer setup which contains an drying chamber, and this is a final collector, and this is a connecting rod which connects the dryer and our air blowers. We can say it is more or less similar to the thin layer dryer, as we seen in before experiments. They both are on the same working principle. They both have same working principle, which we use hot air as an input. From the hot air we are going to dry the material, which we taken as a sample. For this we have to note down for this experiment, we have to first start with measuring of initial moisture content. To measure the initial moisture content, we can go either for a direct by measuring a digital meter, or we can either go for a hot air balloon. For that, we have to take 10 grams of a given sample. Then we have to place that 10 gram to the hot air oven for the time period of 1 hour at 130 degrees Celsius, or 103 degrees Celsius. For that 1 hour, we have to calculate the initial moisture content. For the initial calculation, we can just calculate as initial weight minus final weight, which will be the answer will be the initial moisture content of the taken sample. Okay. Afterwards, we can start the procedure. First, we have to place the given sample in the chamber. We have to pour the given sample in the chambers, and we have to close here. Then we have to start. We have to set the temperature of the air blown for the particular sample. For the temperature, for fixed temperature, we can take out the fixed temperature from the data published from ICR website. We can take the data and we have to fix the temperature here. Once we set it, means we have to wait for the temperature should be attained. Afterwards, we can start the experiment. We can carry out the blower temperature. We have to note down the blower temperature and the initial weight and final weight of the samples at a regular interval. For calculation, it is more or less same to the thin layer calculation. The calculation will be same as the thin layer dryers. First, we can calculate the initial moisture content of the grain. Then, the moisture content of the grain at a time of drying, the initial weight of the grain minus final weight of the grain. As we see already note down here, we have to wait at 10 minutes once. We have to take the weight of the samples. After noting down this, from this we can calculate the moisture content of the individual time period at individual time period. Next, drying rate. For drying rate, the formula is mass of the water removed, that is moisture content removed at the time in kg divided by time in hour. So the moisture content will be, as we have digital moisture content, once we taking the sample out, means we have to check the weight and moisture content of the taken sample. That we can note down here. And then as we assume the equilibrium moisture content in a thin layer dryer, here it is also we are going to assume the thin layer moisture content dryer as 12% for taken sample. For taken sample, which will be vary for different samples. I am just saying an example as a 12%. From that we can calculate this moisture content level, and then we can substitute this for drying rate. After completing this, we have to draw a graph for time against the drying rate constant. After completing this, the experiment will be done. Thank you.